What is up, math magicians? Welcome to section 4.2, graph quadratic functions. And you know quadratic functions are ones that are going to have parabolas in vertex or intercept form. What is vertex form? Vertex form looks like this. You got a set of parentheses and then squared. Set of parentheses squared. Intercept form is going to look like this. Two sets of parentheses and there's multiplication in between. Multiplication in between. My whole goal for today is to help you graph equations that look like this. So these functions here. But before we do that, we have to do one little review. What does it mean to take the average of something? When you average two numbers, you add them up and then divide by 2. So the average of 2 and negative 4, you add them up, you get negative 2, and you divide by 2 to get negative 1. Negative 1 is the number that's halfway in between both of those numbers when you plot them on the number line. So we're going to need that skill today. All right, so first of all, we've already seen finding the number that cancels. So here the number that cancels is negative 2. When you look at negative 2, and then we're going to put that on the center of our table, and then we're going to have a few numbers on either side, as you can see right there. Then we're just going to run it through the function and PEMDAS it out to figure out what the y value is. So this is what it looks like. Negative 2. As you can see, negative 2 plus 2 cancels, you get 0. 0 squared is still 0. Make it negative is still 0. Then you're going to add 3, and then you get plus 3. You're going to need a lot of room when you make these tables in your composition book. It's okay. We can do these calculations. Negative 1 plus 2 is positive 1, and then when you square it, you get 1 still, and then you make it negative, it becomes negative 1. Negative 1 plus 3 is 2. 0 plus 2 is 2. Squared is 4, and then make it negative, you get negative 4. Negative 4 plus 3 is negative 1. Negative 3 plus 2 is negative 1. And then negative 1 squared gives you positive 1, but then you make it negative again, so it comes back to negative 1. Negative 1 plus 3 is 2. Negative 4. Negative 4 plus 2 is negative 2. Squared, you get 4, and then make it negative. Becomes negative 4. Negative 4 plus 3 is negative 1. You can see we still have the same symmetry because we chose that the center of the table really well. We had 3 on this side and then 2, negative 1. 2, negative 1. The symmetry is on either side of the table. When you graph all those points, this is what it looks like. Wowzers. It is shifted over that way, translated over 2 units, and then up 3 units there, and then it's going downward. It's going downward because of this negative symbol over here. It made everything negative. Or just flipped everything. Okay, next. Let's do the same thing again here. What is the number that cancels? Here, it's 3. So put that in the center, and then you just need a few numbers on either side. Let's run 3 through and see what happens. When you 3 minus 3 cancels, you get 0. 0 squared is 0. Times 2 is 0. And 0 minus 3 is negative 3. Let's take a look at 2 on this side. 2 minus 3 is negative 1. When you square it, you get positive 1. Positive 1 times 2 is 2. Minus 3 is negative 1. Here, 1 minus 3 is negative 2. And then you square it, you get 4. And you multiply it by 2, you get 8. 8 minus 3 is 5. Put 4 and you get something very similar. 4 minus 3 is positive 1. Squared, you get 1. 2 times 1 is 2. Minus 3 is also negative 1. 5 minus 3 is 2. Squared is 4. Times 2 is 8. Minus 3 is 5. When you graph all those points, it looks like this. You can see the vertex is down here at 3, negative 3, and they go up like this on either side. Alright, so that's vertex form. It's more complicated than anything we've seen before, but that's okay. You can still make tables, and you can still find the number that cancels. When you see this, there's actually, you're like, Berg, what's going on? I see 2 sets of parentheses, 2 numbers that cancel. Yeah, we're going to have to find them both and use them, although they're not going to be at the center of the table anymore. They're going to be actually here. The number that cancels is 2. The number that here that cancels is negative 4. So put them both on the table, and let's find the average between the two. Average. put the average between the two in the very center, which happens to be -1. We already found 2 plus -4. It turns out to be the average is -1, and we put that right here. And then we could use another number or two on the outside just to get our total of 5. All right, so let's put these numbers through. Substituting, we get -1 minus 2 is -3. And -1 plus 4 is +3. So -3 times 3 is -9. Put 2 in, you get 2 minus 2, which is 0. And then 2 plus 4 is 6. And 0 times anything is going to be 0. 3. 3 minus 2 is 1. 3 plus 4 is 7. Multiply, you get 7. Here, subtract to get -6. Add to get 0. Multiply to get 0. -5 minus 2 is -7. When you add, you get -1, and when you multiply, you get +7. Notice if you do it right, you get that symmetry right there, which is a great confirmation. Plotting all those points, this is what it looks like. You can see the the really interesting thing is that these numbers here, where they get cancellation, you're always going to have a 0 value. So when we said there's cancellation at 2, there's cancellation at -4, it turns out that they're right here along the x-axis, 2, -4. They are the intercepts, and therefore that's why it's called intercept form. All right, here, what the numbers that are going to cancel are -1 and 3, so let's put them on the table. -1 and 3 on the table. Average them. With 3 plus -1 is 2, and cut that in half, you get 1. So the average of these two numbers is 1. We need a couple numbers on either side, and then let's run them through. We get 4. When you add here, you get 5. When you subtract here, you get 1. And when you multiply, you get 5. When you add here, you get 4. Subtract, you get 0. 4 times 0 is 0. We almost could have expected that because this is going to be one of the numbers that cancels. When the number cancels, you get 0. Putting 1 through, when you add, you get 2. When you subtract, you get -2. And when you multiply, you get -4. Let's see, -1. Oh, we knew -1 is a number that cancels, so I could expect this to be 0. And there's also symmetry from the table. Okay, so that I should expect 0 as well. Add, you get 0. Subtract, you get -4. Multiply, you get 0. Oh, from symmetry, I'm going to guess this number over here is going to be 5. Let's see. When you add, you get -1. When you subtract, you get -5. And when you multiply, a negative times a negative is a positive. Let's graph all those points. There they are. The two numbers that we use to cancel turn out to be x-intercepts, and that's why it's intercept form. Plotting all the points, this is what it looks like. All right, let's describe these graphs. Maximum value of y. We already know that the, I don't even bother to say it, the domain is going to be all real numbers for all of them, because you could put any x value you want in here and calculate a y value. That's what it looks like on the table. And then over here on the graph, you could these graphs expand. They just continue from as far left as you want and as far right as you want. There's no lowest x value. There's no highest x value. It's just all real numbers. So let's talk about the maximum y value. Here, the maximum y value doesn't go up to +infinity. As high as it goes is 3. On the table, we can see it goes up to 3. On the graph, we can see the highest is 3. So I'm going to say the maximum here is 3. Here, the y values just keep on going up and up and up and up. So the maximum y value is infinity. And that's true for all three of these graphs, infinity. The minimum y value here, there's no minimum. It keeps on going as low as you want. The graph extends down forever. So that's -infinity. But here, the minimum is -3. You can see on the table here, -3 is the lowest y value we calculated, or possible. And then it's also the lowest y value here on the graph. Lowest y value here is -9, and the lowest y value is -4. So, if you want to know what the domain is, oh, I forgot I put it in a different location. The domain here is going to be all real numbers in purple. -infinity, infinity, -infinity, it's like all 4 of them. But the range is going to be the minimum y value to positive, from the minimum y to the maximum y. -infinity to 3. -3 to infinity. negative 9 to infinity. And you can see that you've got square brackets just to make sure we know that we're including them. Negative 4 to infinity. Vertex. Negative 2, 3. So that's where it's going to be the center row every time. Negative 2, 3. 3, negative 3. Negative 1, negative 9. And remember, although this parenthesis means interval notation, and this parenthesis means grouping symbols in PEMDAS, these parentheses mean a location on the graph. Where's the vertex? It's here, negative 2, comma 3. Transformation. All right, we got a lot of transformations going on. We got a horizontal translation of negative 2. This got shifted over 2 units. We got a vertical translated of 3, up 3 units. And then the whole thing got flipped upside down. It's reflected over the x-axis. So we can say that I call that a vertical dilation of negative 1, but some textbooks also say it's a reflection of the x-axis. Here, horizontal translation of 3, vertical translation of negative 3 went down, and then a vertical stretch of 2. We get that from here. You can see that the function would have been 2. You could have actually also seen the horizontal translation here at positive 3, it's the number that cancels, and a vertical translation of negative 3 over here. But you can also see it from the graph. Here, there is no a value out front, so therefore there's no dilation or stretch. It's just a horizontal translation of negative 1 over and then 9 down. Here, horizontal translation of 1 and vertical translation of negative 4, as you can see. All right, y'all. Thanks for paying attention. I just wanted to pause and just say for a moment, for a hot second, my favorite national park is Yosemite National Park. It's in California. Have you ever been there? Why don't you tell me your favorite national park, or let me know where you like to vacation when you come into class. Take care, and I'll see you soon.